Is the PPT screen visible to you?
Yes, sir.
Okay, let us start. Today we are going to see the topic matrices and then determinants. Okay, in this topic you will be studying in your class 11th and then 12th. In class 11th, mostly you will be having the basics like the basic operations like addition, subtraction, and then multiplication. We can't do division on matrices. Is it clear? Basics. And then in 12th standard, you will be studying the somewhat the determinants for properties and then ranking, some methods like Gauss Jordan method, Cramer's rule, like that you will be studying in the 12th standard. Okay, let us start from the basics. Matrix. If we take a matrix, it consists of a set of values. It is in the square bracket. Matrix should be determined in the square bracket. Let us take 3 cross 3 matrix. This is the n into m, which is this is the number of rows and this is the number of columns. N is the number of rows in the matrix and then m is the number of columns in the matrix. Okay, if you are having 3 rows and then 3 columns, you will be having a1, b1, c1, 3 elements in the row. It is column, right? This is the column and this will be the row. And a2, b2, c2, a3, b3, c3. Okay, determinant. If you go to determinants, it is the value, the whole number value of a matrix. Okay, you will be having a definite value x for the whole matrix by solving it. Okay, let us talk about the minors and then cofactor in a matrix. First of all, what is minor in a matrix? Okay, a matrix can be determined like this, like a11, a12, a13. Accordingly, this is a 3 cross 3 matrix. Okay, and then what is aij here? Like I is the in this matrix, according to the matrix A, I is the value from 1, 2 and 3. J is also 1, 2 and 3. This is the number of rows. I represents the row and then J represents the columns. It is first, if it is 1, 1, I is 1, J is 1, and it will be like first row, first column. Okay, this is the first column and this is the first row. So a11 is the first one, and then if it is a, if ij is 2 3, if it is a 2 3, and this is the second row, third column. Okay, is it clear? They understand the minor. What is minor? Okay, minor is represented by mij. It is this, we are specifying the place of the element in the matrix. Is it clear? and then what we are doing is in this minor, if you are taking this, just a minute, let me tell you how to calculate the minor. Okay, if you need minor for some value, let us take minor for 1 1. You need to skip the row and you need to skip the column. The remaining matrix is the minor of 1 1. What we need to write is A22, A23, A32, A33. This is the minor of a matrix, minor M11. You need to take that value and then delete the row it contains where it is placed, and then delete the column where it is placed, and write remaining elements in a matrix, and the determinant of this is the M11. Okay, is it clear? If you take any other value, let me use different color now. If you take M32, now here is the M32, and we need to remove the row it contains, and then remove the column contains A32, and it will be what is remaining here: A11, A13, A21, A23, and you need to write accordingly: A11, A13, A3, sorry, A21. A31 is A31 is there present in the A32 which contains the row. Okay, and then A23. Is it clear? This is the minor. This is how we are finding the minor in a matrix. Okay, and what are cofactors? Cofactors are nothing but we are adding some signs. Okay, it is cofactor also represented by the same Cij format, which represents the element placed in the matrix. Okay, and if you take, let us take an example of C12. Okay, and replacing the formula like the given standard equation, we will be getting -1 whole power. This is the power here, I plus j. What is I here? I is 1, j is 2, so it will be 1 plus 2 m12. What is m12? We have already seen in this previous slide. We need to omit the rows and columns which consist that element. Okay, so here 1 2 1, so we need to omit the first row and then second column. The remaining is, it will be -1 power 1 plus 2 is 3, and then matrix for this is A21 remaining, A23, A31, A33. Okay, and this will be minus because the power is odd, so it will be minus. You will be writing A21, A23, A31, and then A33 with the negative sign. Okay, you can just directly find the signs without using this formula. Just cofactor is nothing but minus with signs. Okay, it will be the in a 3 by 3 matrix. It is in the form of plus minus plus, and then minus, sorry, minus plus, and then minus plus minus plus. it will be in the alternative way. First plus minus plus minus plus minus. Okay. And if you are finding a term here, taking the same example, it is C12. If you are seeing the C12 place, it already have the negative sign. So you need to take the negative sign and you need to put the minor of that value with the negative sign. Is it clear? This is a simple way without we don't want to follow this standard equation. Just know this logic and then we can directly use the minus, okay, to find the cofactor. We can find the cofactor only with the minus. Is it clear? Okay, let us solve one question on this topic we have learned. No, it is given that let a determinant a is this, the value of a is this, and then they given that C13 is 35, C C31 is 8, and then we need to find the values of x and y respectively. And students, if you are watching this class in YouTube, just type your answers in the comment box. I'm also seeing the YouTube also. Let us see how many of you giving the correct answers. Okay, just take a minute. Try to solve this. Okay, students, are you solving this question?
Yes, sir.
Okay, just take a minute. Not more than that. We will be solving next question. We will go into next question. Okay. If you completed your answer, just let me know in the comment box or chat box. Okay. Let me now solve this question. Let us rewrite this determinant once again. They were given that determinant A is okay. What they have given is in the matrix they have given 1, 3, x, 4, -5, 6, and then y, 5, 2. and then they have given that C13 is 35, and then C13 is 35, and then C31 is 8. We need to find the values of x and y. Okay, first of all, what is C13? It is the, if you take plus minus the term, it will be, this is the C13, sorry, C13, and it will be plus minus plus. So here it is plus of M13, just the minor of 13. Okay, and then what is C31? It will be here minus plus minus plus minus plus. So C31 also it is positive, so it will be the positive of M31. Now what is M31? Let us do the determinant. Okay, without we need to omit the rows and columns which is containing the value 13. Okay, we need to neglect this term, so we need to neglect the row 1 and then the column 3. So we will be writing 4 minus 5 y and then 5. And what is the value of C13? It is given that 35. We are going to solve this simultaneously. Okay, and then what is the value of C31? It is given that it is 8, right? And then we need to write the minor for 31. Let us do the determinant. And then what is 31? We need to omit this row 3 and then column 1, right? Without taking that, you will be getting 3x minus 5, 6. Now let us solve this determinant, and then we will get the values for x and y. Let us solve this. Hope you are you know the process how to solve these determinants. Okay, you need to cross multiple the terms so that you will be getting 35, which is equal to 4 5s are 20, and then minus and multiple this term, it is minus 5 y. Okay, it will be, here it is 20. Okay, and it will be, you will be getting, if you are solving this equation, you will be getting y as the 3, and then for the solving this side for 3 1, for we are going to get x in this term, so we will be getting 18. Here you will be getting minus and then minus into minus plus, so it will be 5x, and your value of x will be minus 2. Now you found that values of x and y is minus 2 and then 3. And if you see this, your option A is the right answer. Have you got this answer? Option A is the correct one. If you are not getting, the video will be available on YouTube. You can watch again after this session at any time. Okay. Okay. Let me tell you some important thing here at this point. Okay. The, you need to just make note of it. The sum of product of any row with their corresponding cofactor is value of determinant, which means if you are having a row, let us take a11, a12, a13, A21, A22, A23, A31, A32, A33. Okay, here we will be getting, they are saying that we will be getting the value of determinant. Okay, we will be writing determinant using this delta symbol. Okay, the sum of the product of any row with their corresponding cofactors, which means if you take A11, the corresponding cofactor of C11, and then you need to sum it with A12, C12 plus A13, C13. This will, if you are solving like this, you will be getting the determinant of the given matrix. Okay, this is the first statement is trying to convey you. And then the second statement is the sum of product of any row with corresponding cofactors of other row. Okay, other row or column. Here we are not only mentioning the row. Okay, you can take this column also. You can make determinants by taking this column 3 like A13, C13 plus A23, C23 plus A33, C33. This is also, this also gives the same value, the same determinant value for the same matrix. Okay, and then if you change the cofactor of another row or different column, you will be getting, definitely getting 0. Okay, let me tell it here. If you are having A11 and you are writing cofactor for the second row, which is C21, and then plus A12, C22 plus A13, C23, and the value will be 0. Okay, this is the thing we can overall conclude that what we have learned from the minor and the cofactor. Is that clear? If you have any doubt, just ask me in the chat. Okay, you are given the option A. Option A is the correct answer. Nice. Okay. Now let us see some properties. If you take any chapter, it has properties, and these properties means many. You can surely get 4 marks if you just go through these properties. Okay, these are the basics. With these basics, you can solve n number of questions. Okay, let us go through this first property. Okay, the value of a determinant remains unchanged if its row and columns are interchanged. Okay, let me explain it with an example. Let us take a matrix which is A1, B1, C1, A2, B2, C2. We can take any matrix like which is 3 cross 3, 2 cross 2, or 2 cross 3. But this is like, for example, it will be very easier to understand this. Okay, so that I am taking this 3 cross 3 matrix, and let us take let us assume that the determinant of this matrix is some x. Okay, and then what happened is, let us change some rows. What do you mean? Okay, let us write like this: a1, b1, c1, a2, b2, c2, a3, b3, c3, and the determinant of a is also b, X no. If you see here, this row we have changed like this. Do you understand this? We have changed the column and we have shifted it to the row. Okay, and in matrix they will tell this as transpose. Let us take this the determinant, and then this is the determinant, or let us have him with the same matrix A. Okay, the determinant of matrix A is equal to the determinant of matrix A transpose. Transpose is nothing but you are changing the rows, you are interchanging. Okay, you are interchanging the rows and columns. This is the transpose. Okay, you are just shifting the column 1 as row 1, and then column 2 as row 2, column 3 as row 3. Hope you understand what is transpose, and if you even do transpose, the determinant will be same. The value of the matrix will be same. It won't be unchanged. Okay, we can denote transpose as like this, or also we can make it like this. Okay, and this is known as transpose. Of course, the track you are changing A into A transpose. This is transposing. Okay, and let us see the second property. Okay, hope you guys understand the property 1, which where we are just interchanging the rows and columns and we are getting the determinant same. If you have any doubts after the session, just go through the video again. Once again, you will be getting clarity. And still, if you are having doubts, just do comment on the comment box. We will reply to that. Okay. Let us see the property 2. If any two rows or columns, okay, they are mentioning we can take any two rows or columns of a determinants or interchange, the sign of the determinants changes. Okay, what they means here is, let us take one practical example of like practical example means we are taking some values for the matrix. Let us take 1 2 1 1 2, and then 3 1 1. Let us take here 4 1 1. Okay, if you are doing taking determinant for this, determinant of A will be 18. Okay, if you are solving this, just I am telling that if you are solving this, you will be getting 18 for this determinant value. And what they have told here is any two rows or columns. Okay, in the first case we have completely changed all the three rows and columns. Okay, but in this case we are just changing two. Okay, let us take it is A1, and it will be 1 1 2 4 1 1 3 1 1. We have interchanged these rows. Okay, and then if you are taking determinant again. If you are checking the determinant, you will be getting minus 18 as your answer. Okay, it's nothing that determinant of A is equal to negative of the determinant of A1. Is it clear? A1 is nothing but just we have interchanged the rows. Or else if you are taking A2 some, we can change the column also. We can take 1 1 1, 1 3 4, and then 2 1 1. Now also you will be getting minus 18. Determinant of A is equal to negative of A1 and then negative of determinant of A2. Hope this is clear to you. And then let me tell you one more remark on this. Okay, just notice this is a remark. Just note it down. It is important. If there is odd number of interchanges, determinant value will be negative, and even number of interchanges, determinant value will be same as the positive. Okay, we can't say like it is negative positive, but the sign change. Here we are mentioning that sign changes. The determinant value can change. Here the sign will not change. Just make note on this. Like here we are just switching one. Okay. Instead of two three, we are just replacing two with three. Just one interchanges happened here. If two interchanges happens, like if interchanges happens here, it will be looking the same matrix as the first we have seen. Okay, and then let us see the property 3, and we are having still remaining this property 3 and 4, and we will wind up the session for today. Okay, property 3: if any two rows or columns of a determinant are identical or all corresponding elements are proportional, then the value of the determinant is 0. This saying, if you are seeing any matrix, any determinant with same type of row or column, it is the value of the determinant is definitely 0. Okay, they can in exams they can give a big matrix with two similar rows or columns, and they can ask for the determinant value or some values with the help of that. Okay, with the help of that they can frame new question and then ask the value for that. So you should first check whether this determinant has similar type of rows or columns. Like let us take an example for having determinant of a b c e f g and then again a b c. Now this determinant value is 0. Let us take one numerical example like this. If you are having 2 3 11 and then 4, 6, 13, 6, 9, 17. This also equal to 0. Now, let me tell you why this is 0. You can ask like, so you are told if you are having two similar rows or columns, you can have 0, the determinant 0. But in this case, in this determinant, you are not having anything similar. Two rows or two columns is not similar here. But why we are putting 0? Why? Because let me tell you, this column 1 is in the multiples of 2. So we can take 2 as the common from the row 1, sorry, column 1. So it will be 1, 2 and then 3. If you see column 2, it is in the multiples of 3. So you can take 3 also outside the determinant so that you will be getting 1, 2 and then 3. And you will be having the column 3 with no similarities. So it is the same. Actually, this is the prime number, so you won't have any similarities. And now if you see this, you are having two common rows. Okay, you need to check these also in your exam. Just it will in matrix, according to matrix and determinants in the examination, it is a little time taking one, but you can get marks easily in these topics. Okay, you need to just need to know how to consume the time in the exam one. It will come by practice. You need to solve more PVQs. Okay, hope you understand the property 3. And then let us finally come to the property 4. If all elements of if all elements of any row or column multiplied by a number k, then the values of determinants also multiplied by k. It is nothing like it is the similar one we have done in this. Okay, what we have done, we have took 2, we can multiply it to the row or column here, we are, and then 3 to this column. Okay, this is the reverse, the exact reverse of this. If you are having some matrix A1, B1, C1, A2, B2, C2, A3, B3, C3, you are multiplying some k with this term, and then you can multiply this k with any one of the row column. Okay, you can choose this row, this, any one of these three rows, or if you don't like that, you can take any one of the columns. Like we need to choose wisely which column or row we are going to choose. It will it will useful for the further steps. Okay, you need to see accordingly, and then you need to add, means take common or multiple it into the determinant. Okay, it is b1 k c1, and then it will be same here, or else you can write it as ka1, ka2, ka3, and all the terms again same terms. Okay, as I told you before, we can also take common terms. It is the reverse. Okay, we can just note down this remark. Can take a row or column multiple and number to a row or column in a determinant. Okay, is it clear? Okay,
Yes,
let
sir.
us just have a final summary of today's session. Okay, today we have just started the matrix and the determinants topic, and we have just seen the rows and columns and determinant type, and we found how to find a minor, what's a minor and how to find it, and then what is cofactor and how to find that cofactor, and then with the help of cofactor we can also find the determinant also. Okay, and we have seen a question for a given matrix, and then the cofactor values are given and we need to find the elements. Okay, and then we just have some few important points here. If you are not note down this, just please note down this, these are important one. And then we have seen properties, which is we can change any rows and columns. If you change the rows and columns, the value will be same. If you change any, it is a property one. If you change any two rows in a determinant, you will be having the opposite sign, negative sign. And in the property 3 says, if you are having two identical rows or column, the determinant will be 0 at last. And then the property 4 says you can either multiple a term to a row or column in a matrix, or take common from a row or column in a matrix. Hope you understand this session. If you have any doubts, you can ask, and we will wind up this session.
Thank you, sir.
Okay, thank you. You can leave the meeting. Okay, students who are seeing this class on YouTube, if you have any queries, just do comments. If you have solved the questions, it is nice. And we will be having our sessions from 8:15 to 9, and then 9:15 to 10. Don't miss out our sessions. Let us crack JEE by this crash course. Okay, fine. Thank you.